How to show events are independent. Example 2. Two events A and B are such that the probability of A is 0.5, the probability of B is 0.4, the probability of A given B is 0.3. We're firstly asked to find the probability of A intersection B. The rule for conditional probability will be used to help find this. So we know that the probability of B is equal to the probability of A and B divided by the probability of A given B. We know this is always true. I'm going to use this formula. It's because we know what A given B is. So that's the formula to use. Rearranging this gives us the general multiplication formula that's always true. And that is that the probability of A intersection B is always equal to the probability of B multiplied by the probability of A given B. And this is true whether it's independent or not independent. So this is the formula we're going to use here. So the probability of A and B is equal to the probability of B, which is 0.4, multiplied by the probability of A given B, which is 0.3. Multiply these, we get 0.12. So that's the first bit worked out. Nextly, we've been asked to investigate whether events A and B are independent. The answer to this question is obvious from the question already, because the probability of A is not equal to the probability of A given B. We can see that these are different. And if events were independent, the two of these would have to be the same, because by definition, independence means that A is not being affected by B. But we see in this example, the probability of A, which is 0.5, is not equal to the probability of A given B, which is 0.3. Therefore, the events clearly are not independent. There is a second approach we could have taken to this. We could have used the multiplication rule for independent events and seen that the probability of A multiplied with the probability of B, which is 0.5 by 0.4, gives us 0.2, and that's not equal to the probability of A and B, which is 0.12. But there seems no need to do this here because it's apparent from the question that A and B are not independent.